So we are going to be considering the geometric distribution. This distribution is different from the binomial distribution or the Bernoulli distribution in the sense that this distribution considers uh, the attempts that will be made in a different way. All right, now a geometric distribution can be of two types. It can be of type 1, and if it is of type 1, then it means that we are concerned about the number of trials until the first success. What do we mean by that? That means we try maybe once, we try the second time, the third time, the fourth time, and perhaps our success may happen the fourth time. So if we don't get success, we'll continue to try. That's why you see 1, 2, 3, and because we do not know how many times we'll perform the experiment before we get success, that's why we continue till infinity. So not necessarily till infinity, but as a general case, the number of trials may be larger than you may imagine. It may come the first time, success may be obtained the first time, the second time, or the third time. You can't tell. So you keep performing the experiment until you have the first success, then you stop. So sometimes the success may be the second time, it may be the first time, it may be the third time, it may even be the 100th time. All right. Now that's the first type of geometric distribution. The second type of geometric distribution is one that models the number of failures before the first success. Now, this case, it's easy to see that what we are calling our x here could have actually been defined as this one minus 1. So remove 1 from here, you get 0. So this, you get, all right, let's do it this way. Assuming in this case, the third time was when the success came. All right, we are counting all the failed attempts. That means we had 2 failed attempts, 1, 2. So the third time the success came. So, but here we are not going to count. So in this case, we are going to count the first failed attempt, second failed attempt, as well as the time when we now have success. So we are going to say, okay, x, that means we had 3 trials here. 3 trials before we had a success. But in this case, we are only going to count the number of failures. Okay, let's say 3 trials until we had a success. So we count the number of failures, the 1, 2, those attempts, and then we'll come back to the time when we made success. So we'll say, all right, we had the first success on the 3rd attempt. Okay, so we are counting the failures as well as the attempts, but here we are only going to be counting the failed attempts. So it means that in this case, if we tried and got success the 3rd time, we will only count the first time and the second time because we use the word before the first success. So because of that, we are not going to count the 3rd attempt. So in this case, we may look at, okay, any failure before the success, I mean the first success, no, that will be 0. Any failure, okay, how many failures? The failures could be 0, no failure. That means on the first attempt we had the success. Okay, no, 1 failure. It means on the second attempt we had the success. Okay, no, 2 failure means that on the 3rd attempt we had a success. That's the meaning here. So in this case, we are going to be saying that if we got the success at the 3rd attempt, then this particular distribution here will say, okay, we had 2 failures before the first success. All right, but this particular distribution, the type 1, will say, no, we had 3 attempts. So on the 3rd attempt, we got the success we were looking for. And so that's the difference between the 2 distributions. But for the sake of what we are doing at this time, which is just to introduce the probability, the concept of probability distribution. We will not be using the second type for our calculations. We will only use the first type. All right, so the first type is important. The second type is also important, but we will concentrate on the first type. All right, so which means we are going to be considering X as the number of trials until the first success. But in the second one, X is the number of failures before the first success. So it's good to take note of the two. All right, now these are the properties of the geometric distribution for the first type. The first type. All right, so the mean will be 1 over p, the variance will be q over p squared, where q is 1 over 1 minus p, and then the cumulative distribution function, that's the CDF, will be this, and then there is a sequence of independent trials. When you are doing the geometric distribution, you have a sequence of independent trials. Each trial is independent of the other. So one trial does not, no trial affects the other trial. All right, there are only two possible outcomes. So you may have something like on or off, success or failure, male or female, at home, not at home, and like that. Now, there is a constant probability of success for each trial, and that probability is P. This P we're talking about here. All right, the P here, this P, this one. All right, now there is, okay, the random variable of interest is the number of trials until the first success is obtained. So you keep trying. If you obtain the first success in the first trial, you stop performing the experiment. If you obtain it in the second trial, you stop. If you obtain in the third trial, you stop. If not, you continue. So perhaps it may be in the 10th trial or the 100th trial before you obtain your first success. All right, the mode of the geometric distribution is 1. And of course, the PMF, the probability mass function of the geometric distribution, is this one. That is when we are considering type 1, the first type of geometric distribution we have discussed. This is not like a standard name for the geometric distribution. I have only used type 1 and type 2 to differentiate between the two. All right, so let's look at properties of geometric distribution again. Type 2. For the type 2, in case you're interested in it, the mean will be this, q over p. All right, you know what q is. The variance of x will be q over p squared. The cumulative then distribution function, the cumulative distribution function will be what you're seeing here. And then there is a sequence of independent trials, just like the first one. There are only two possible outcomes, like the first one, like the type 1 geometric distribution. There is a constant probability of success, like the type 1, like in the type 1 geometric distribution. And then, but this time around, the random variable is the number of failures. Is the number of failures until the first success is obtained. And then the mode of this type 2 geometric distribution, sorry please, the mode of this type 2 geometric distribution is 0. So the mode of the first one of the type 1 is 1. And then the probability, the probability mass function is P multiplied by Q, all of these that you can see on the board. All right, so that differentiates the two of them. Now we have known this. We can look at some examples since we know the properties of geometric distribution, we know when it is to be used. We can look at some examples. Okay. All right, so some exercises. Now, the first one, suppose a man and his wife want to give birth until they have their first male child. Now, this is the type 1, and that's the only one we're going to be considering in our example okay, in this course. And it says, suppose that a man and his wife want to give birth until they have their first male child. So we don't know how many times they are going to give birth until they have their first male child. It may be 3 times, it may be 4 times, it may be 5 times, it may be 6 times, it may even be the first time. All right, so, but we need to find the probability that they will have a male child in 10 trials. 10 trials. So, and we've been given the probability that they will give birth to a male child. So now we have to find the probability that they will have a male child in 10 trials and find the mean number of trials and the variance. So let's go again. Suppose that a man and his wife want to give birth until they have their first male child. So this is what you should look for at any point in time. Once you see this, you know that it's going to be a geometric distribution. How? They are performing until the first success. In this case, the first success, what is called success, is a male child. All right, so as long as they give birth to females, they don't have a male child. And until, they don't have a success as long as they give birth to a female, until they have a male child before you say, okay, they have a success. And so the probability that they will give birth to a male child is 0.5. Now we are told to find the probability that they will have a male child in 10 trials. So now, and we're also told to find the mean and variance of the number of the mean and variance of the number of trials. So the mean and the variance. All right, now coming back here, the probability that the number of trials will be x is what we have here. That's the probability mass function. And so now we intend to find the probability that x will be 10. So we know that our p was given to be 0.5, which means our q, which is 1 minus p. I think I need to make that one obvious here. All right. We just need to add something like equal to q. This should be q. So q is equal to 0.5, and then we have 0.5 multiplied by 0.5, then that's 0.5 now raised to the power of x minus 1. And then from there we'll go forward to say that okay, when x is 10, so for 10 trials, x equals to 10, it will be equal to 0.5 times 0.5 raised to the power of 10 minus 1, and approximately your answer will be what we have here. All right, the mean, we already know that the mean should be 1 over p, and because we know that, we can just substitute everything that we need to substitute, and p is 0.5, so we get a 2. If you like, you may go on to say, okay, you may say p of, expected value of x equal to summation x p of xi. So you may have xi here, and then you put this here. If you like, you can say I takes values from 0 to infinity, but that will involve a lot of stuff for you because you are going from 0 to infinity, and that may not be what you really want. So it's been found if you do that, you follow the geometric kind of thing, you should be able to get this. You get that, but it's been found, so there's no need to bother doing that. So there's no need to bother yourself about that. Now, so the variance is now going to be q over p squared. So the variance will now be equal to 0.5 divided by 0.5 squared, and that will be 1 over 0.5, and that will give you 2. Basically, the variance and the mean are the same here because we have 0.5 as our P, and that is equal to Q. But that is not the case in every situation. All right, so let's take another example. Find the probability that a young politician, not politicians, a young politician will win an election in 5 attempts if he has chosen to succeed, or rather, if he has chosen to continue to contest until he wins one. Okay, and you are not given that the probability that he will win is 0.62. You're also told to find the average number of attempts. That's the same thing as looking for the mean number of trials. So mean number of attempts or average number of attempts, the same thing. So then you are also told to find the variance and the standard deviation of the number of attempts also. And so in this case, probability of x equals to x is this, our PMF, as we have always known, the probability mass function. And then because we know that P is 0.62, we also know that Q will be 1 minus P, and that will give us 0.38. So fixing all of that here, we can now find the probability of x equals to 5. That gives us 0.62. Now, P is this. Q is this, 0.38. So we fix them, and then we have probability of x equals to 5. Put our 5 there, we get 0.00129. And then we can look for the mean, 1 over P, and that would be 1 over 0.62 in this case, and that gives us 1.6129. And the variance of x will be Q over P squared. That gives us 0.38 divided by 0.62 raised to the power of 2. And that gives us 0.9886. Then the standard deviation can always be obtained from your variance. Just find this, you just look for the square root of the variance, and then you have your standard deviation. All right, at this point, I'll leave you to get some examples. You may do them by creating them yourself or looking for some from maybe your courseware or from the internet or something, and then you can try to solve them. So, but before we go, it is important to know that although the binomial distribution, in the binomial distribution or Bernoulli distribution, we know how many times we are performing the experiment, but we do not know how many times we'll be performing the experiment in the case of the geometric distribution before we have success. So let's go. What I'm saying is that if we talk about the Bernoulli distribution or binomial distribution, so let's take binomial in general. Binomial distribution says I want to perform the experiment n times and obtain x successes. So usually what we say is look for, okay, a man is doing something n times, and he wants x successes. But the geometric distribution says I want 1 success. Geometric distribution says I want to perform the experiment until I have 1 success. So you don't know how many times you're going to be performing the experiment. That's the implication. It may be 5 times, it may be 6 times, it may be less than, you don't know. But you know that once you have 1 success, you're going to stop performing the experiment. So that's the difference between the two. All right. So that's the difference between the two. So geometric distribution, as I said again, says I want to perform the experiment until I have just 1 success. So I will stop So it means that you don't know the number of times you'll be performing the experiment. But binomial says I want to perform the experiment n times and obtain x successes. So when I have even if I don't have x successes, I will stop after n times. That's what the binomial experiment says. The binomial says I'll perform the experiment only once. So I may either have a success or no success. But the geometric distribution says I want to perform the experiment until I have one success. So a young man wants to get admission or wants to obtain admission into the university, and he keeps trying. Perhaps he may try 9 times. That means 9 years until he gets the admission, or he may be trying multiple sources. So in a year, he may have 3 attempts. He tries JAM, he tries JUPEB, he tries interim JAM, he tries perhaps any other way, remedial, and maybe he may have 4 attempts in a year. Those are so if he gets the admission at any point, he stops. So that's just what we are trying to say here. And